So, show of hands, who's heard of Airflow? Yeah, and how many of you use it in production? All right, a little bit less. Yeah, so currently, if you think of Airflow, it's become ubiquitous for defining and expressing DAGs, which makes a lot of sense. For data scientists and data engineers, it provided three things. One, sort of this abstraction to define your workflows with tasks. So you have these operators that allow you to read from S3 and then write to Redshift, right? Second, it provides this scheduler, so you can then, as you define your workflows and you stitch them together, then you can execute it on a periodic basis, like hourly. And the third one, it provides a UI, where you can kind of see the progress of your workflow. But that's just a small story in your data ecosystem. All right? So with data lineage, it's helpful to have it within Airflow, but as you expand and your data platform scales, you want something that gives you lineage across your data landscape. And that's where Marquez comes in. So my talk today is going to be about data lineage with Apache Airflow using Marquez. Right. So yeah, a little bit about me. I'm Willy. I'm a software engineer at WeWork. I work on the open source project Marquez, which is a team based out in San Francisco, and we're part of the data platform team. In terms of the agenda, we're going to talk about a few things. We're going to ask the question, why metadata, and also why WeWork is investing actually a lot of effort, which is pretty exciting. It's kind of rare, in metadata and sort of how we're building our data platform around metadata collection. We're going to do an intro into Marquez. I'm going to talk about the APIs, the data model, and also what it takes to run it in production and what we're doing at WeWork. We're going to talk about the Marquez and Airflow integration, specifically the Marquez Airflow library that begins to, as your DAG executes, it starts reporting metadata to Marquez and begins to build out that lineage graph. I'll do a quick demo to show you sort of side by side. We're going to run Airflow, vanilla Airflow, define a few DAGs, and then kick them off, and then look at the Marquez UI and see the type of lineage graph and type of metadata that we're collecting. And then we're going to talk about the future work. There's still a lot of work to be done on the project. We're still very early, but still super exciting in terms of the where we can take the project. So, show of hands, how many of you written an ETL job? All right, a lot of you, yeah. So as data engineers and data scientists, we work with limited context. So what that means is you have to ask yourself, where's the data? What's the source? And also, once you find the source, you have to ask yourself, well, okay, if it's in Redshift somewhere, I need to know the tables, which could be very hard. You could have thousands of tables, so how do you know which one is relevant for the type of question you're trying to answer? Then once you find it, it's like, okay, what's the schema? That becomes really critical when you start defining your pipelines. And does it have an owner? I mean, a lot of the time, you kind of default to whoever accesses the table the most, which is probably not a good indicator, but I mean, it's a good start. The other thing you can do is you can blast an email. It's like, hey, does anyone know who owns this data set or this table? And I need help. And then the other question becomes, how often is the data updated? So that's a pretty critical thing to know. Is my data in multiple locations? Is it copied somewhere? Is it represented as Parquet, Avro? Is there a flat file in S3? So the data could be represented in multiple ways. But really what we're trying to get to is data contextualization. So what that means is, okay, I have this blob of data, but I want to learn more about it. So there's a source, like we talked about. So you have MySQL, Postgres, Redshift, Snowflake, and Kafka. Yeah, Kafka is a pretty big one. At WeWork, we do use Kafka to process occupancy sensor data. So is a phone booth open, or is it occupied? The other thing is with formats. So once you have the source, there's various formats that your data can be represented at, and in this case, CVS, JSON, Avro, and Parquet. So they all have their different use cases and their importance. But you want to know the source, the format, and that's a good start. So with Airflow, if you know where you can read the data from, you know what operator to use. And if you know how the data is formatted, then you know what kind of libraries you need to use to parse that file. All right. So why metadata? And really, we're asking ourselves, how could I locate, or how could I make the data sets that I'm trying to interact with meaningful and discoverable? Right. So why manage and utilize metadata? There's three key things. One, data quality. I think that one may not be too obvious, but you kind of want to know if I'm the type of data that I'm interacting with. Do I trust that do I trust that if I'm going to use in my reports, it's actually going to produce reports that are correct? So you have to ask yourself, if it's coming from a table in a warehouse table, does it have a description? Does someone own it? How often is it updated? So really the similar questions that we were asking before, that's a foundation for you to start thinking about using it in your pipeline. Then you have data lineage. So once you have a source of truth that you trust, there's going to be workflows that derive data sets from that source. Okay. So with data lineage, you're able to identify where does the quality break down. It's normally downstream. So if your upstream source is MySQL or Postgres, and you have your pipelines that are processing that data, but there's a bug, downstream jobs will be affected. So you want to understand what's the origin of my data, what kind of intermediate processes are deriving data from that upstream source. Right. And the other thing is democratization of data. This one is just self-service. So after how quickly can you identify the source? So if I'm going to work on a pipeline, how quickly can I identify that source? Do I know its schema? Do I need to ask people for it? Do I need to reach out to someone in Slack? Really, we want that to be all self-service and minimize the amount of time someone's spending to identify what they need in their pipelines. And it's all for creating, we're working towards creating a healthy and data ecosystem. So what that means is we want every employee at WeWork to interact with similar and the correct versions of data. And as we started building out the next-gen data platform, that's what we were thinking. We were thinking about self-service, so providing a way that we can integrate with all of the components of the data platform to start cataloging the different data sets that are available or are being produced and consumed, and making that discoverable, making that an option for our end users to start interacting with. In this case, it would be a Marquez UI, which I'll demo later. You want the freedom to experiment. So there's, a lot of the time you kind of find data sets that might be interesting. So at WeWork, we care a lot about room bookings. In this case, you might think, hey, let's write a pipeline that is going to give us the top 10 locations in San Francisco with the most room bookings. And also, we want to know what kind of fabric is used in the chair. I mean, for us, we care a lot about that. So imagine if you just had a pipeline, you ran it, and the data set is automatically captured by a metadata API, and it could be made available to someone that, if they start searching, like, oh, wait, why did someone compute this? Can I use it in my reports? So really around freedom to experiment and say, hey, I ran this. If this is meaningful to you, start using it in your reports. And that goes into accountability. So as you begin to experiment, you start using resources. So we want to tie the type of data pipelines that are processing high volume of data. We want to associate that cost to a team. So this one, like I was saying before, the amount of time. I think the investment that we're seeing, I'm seeing at WeWork in metadata. If we go to the way we built out our data platform, we built it around Marquez, so metadata collection. So we have ingest. So we have a team out in New York working on an event ingestion API. So every event that makes it into our platform has a schema. So we register that schema with the schema registry, and also we create a Kafka topic behind the scenes, and we register that topic along with the schema to Marquez. And we're starting to see a higher use of streaming applications. So we're working on integrating with the Flink APIs to start supporting metadata collection from streaming apps. And the bulk of my talk will be around Airflow. So we're going to talk about the work we've been doing to begin to capture data lineage from Airflow, and also additional other things around the additional metadata that we're collecting. And the other one for storage, we have a team out in New York that is working on a data abstraction layer, and they're using Apache Iceberg. If you guys haven't heard about it, check it out. Essentially it's a table abstraction on top of a distributed file system, and it allows you to read, write, delete files in an atomic way, and also it's non-blocking. So it's an exciting project that came out of Netflix, and something we're integrating with in order to version file systems with Marquez. All right, so let's learn more about Marquez. So when we first started talking about the project, we were really referencing past experiences. So my background is in stream processing. I built out a number of streaming platforms. And when we started talking about the project, we realized there's nothing really out there that allows us to really catalog or log the flow of data within a platform. And that's only one part, but then how do you make the data sets that are produced and consumed discoverable? Shortly after we talked about the project and started working on it, I found out about this paper called Ground. It's published it came out of UC Berkeley. And the three things that it talks about is sort of this agnostic data model. And then also it goes into immutability, why immutability is important for your data sets, as well as versioning. And those are very similar things that when we were building out Marquez, we cared about the data lineage aspects of tracking data as it transforms over time, making data sets discoverable, and the other one is data governance. So that's a big one for us. So if you want to add some sort of access control on top of data sets that might be sensitive, so data governance begins to provide a flow that if your pipeline wants to read data from a source that needs additional credentials or additional access, or you want to be able to, you want to make sure you have a flow for that. So the design, Marquez is a metadata service. It's a REST API. We went with Drop Wizard, so it's written on the JVM and using Jersey for the REST API. And the backend is a Postgres instance. But at its core, it's just central data metadata management. So the three things that we care about is sources, data sets, and jobs. And similar to the Ground paper, the API itself, or the data model, is agnostic to the type of framework that you're using. So sources, data sets, and jobs work, they map very well to Airflow, but they also map well to Flink and things like Spark as well. So when we thought about the data model, we wanted to make sure that it was very precise, but also we do have a lot of opinions in terms of what kind of metadata we're collecting. The other thing is that the service itself is modular, so there's three components. Excuse me, there's a core API, which exposes the API to start collecting metadata around jobs, data sets, and sources. But then there's the lineage piece. So as you start interacting with the metadata, depending on your access patterns, a relational database is not going to work. So you want something like a graph database to support data lineage queries. And then the other thing with search, you want, as you start collecting data sets and register jobs, you want to make those searchable by description, who owns the data. So all that we're indexing and making sure that our end users can start searching for jobs and data sets that are relevant to them. So the power of Marquez really comes in the integration, so the APIs and libraries. And in this case, the example is Airflow and the Marquez Airflow library that we have. Then just below that, so as the integrations with the different frameworks using Python clients and Java clients that we have, they start reporting metadata to the core API, and the core API begins to replicate that data to our Lineage service, and then also to our search service. And really at the foundation, it's the metadata itself. So in terms of interacting with it, accessing that metadata depends on your access patterns. So like I mentioned before, Marquez has a relational database for its core model, but to build out the lineage graph, we're using Kaylee, which is an open source project from Google. And then for the search backend, we're using Elasticsearch. All right, so this is the core data model of Marquez. There's actually a few tables that are missing, but at the core, this is what we care about. For one, the job, so we care about the inputs and outputs of the job. So a job has one or more versions, and a job version is managed on the back end by Marquez. So it looks for the different, it looks if the inputs and outputs changed. If they did, that's a new version. Also, if the code, so we have a link that we build in the Airflow integration to the GitHub repo. So that way, if that changes, if your commit changed or you updated your code, that creates a new version. And runs are based on our instances of job versions. So it's very important for us to tie the inputs and outputs to the version itself, and then create instances of those runs based off that version. Then each run will have its own run args that we collect. We also capture the metadata around its run state. But the inputs and outputs also are tied to sources. So the first thing that you need to do is register a source, MySQL, Redshift, and then associate those data sets to that source, and then we begin to version the data sets after a job is run. So we tie data set versions to job runs. And the type of versioning that we have is DB tables. That's a fairly simple one, where if your column change or your type changes, that's going to be a new version of the table schema. The file system, that's where Iceberg comes in, and we're working with our team out in New York to begin to add that support to Marquez. And this is something we did recently, was stream lineage and stream versioning. So what are the design benefits? So why have this highly dimensional model? One, you begin to understand where the breakdown happened in your workflow. So a lot of time you push out code to production, you really don't know about until after a week later, where your reports are messed up. You're like, wait, what's going on? There's a drop. Was that noisy data, or was there a bug in code? So you have to go back. It's like, what if I follow the data lineage graph all the way up to the job where the error was introduced? You could then look at the downstream jobs that were affected and be able to understand, okay, they were using this version of the data set that was outputted by this version of the job. And then you'd be able to, then backfilling actually becomes very trivial. You know which jobs were affected, so you don't have to either say, you know what, we're not going to worry about it because backfilling is really hard. Or in this case, you could address it very quickly and notify the teams, hey, by the way, we had some bad data, and you need to run a backfill. So backfilling comes in two ways, so full and incremental processing. So full processing means I want to reprocess all the versions of the data sets, but also incrementally. So some jobs don't want to process all the data that's available. You want to work with a subset, and that's where versioning of data sets becomes extremely valuable. So how is metadata reported to Marquez? It's all push-based. Really, we care about the inflection points. So when your job comes up, or when it starts, you want to report metadata to Marquez right away. So when I'm connecting to a source, that's where we want to report metadata, and also ask Marquez, hey, by the way, how do I connect to this source? And also when the job is complete, as the job is running, we report the job run state. And then when it completes and writes to the source, that's where we want to tell Marquez, by the way, I just finished processing this data. This is the version I produced. Can you register that? And it's all done through a REST API, so it's highly opinionated, and it's around, we have metadata like APIs around sources, like I mentioned, data sets and jobs. And we worked with, so we have 3 languages that we currently support for our clients. Java and Python are in our public repo. Internally, we're working with a team to build out our Go client. Okay, so what kind of metadata are we actually collecting? And it goes through different phases, or different steps, I'm sorry. One, we care about the source. The first thing we need to do is name our source. In this case, we have analytics.db, and we need a connection URL. We also care a lot about the description. That becomes pretty critical when we start searching for data sets and sources. So if you provided a description, we want to make that the search results for this source a lot higher in the resulting set that you get back, because you put in the effort and you should be rewarded for it. So in this case, we're going to give it the source of type. It's going to be Postgres, and now we can start registering data sets. So what metadata do we care about in terms of data sets? So we have to give it a type. In this case, we have a DB table. We have to give it a name and also a physical name. So this is important. The name of the data set, all that are being registered Marquez are logical names, and that's just a user-friendly name. And then the physical name becomes, what is the name that's represented in the source itself? So a good example would be Kafka. So you normally define an event stream and give it a name like room bookings, but behind the scenes, the way you name your topics are going to be a lot different. So you want your end users to interact with the friendly name and not the actual physical name itself. So then we collect the namespace. So we register its columns, so types, descriptions, and so forth, and the description, and then the data set description itself. And then what we can start doing then is start registering a job. Since we register our data set, we can now specify that as its input. And in this case, this job doesn't have any outputs, but really it's a job that runs and just sends out a weekly email. So the key thing that we're doing here is we're linking a source to a data set, and then linking that data set to the job itself. And that really is the foundation of how we build out the Lineage graph. And the other important thing is about ownership. So the namespace is how we tie owners to the metadata itself that we're collecting. So namespace are just logical groupings of your metadata specific to jobs and data sets. So if I walk through how we build out the Lineage graph, so as the APIs are coming in, we just have a little hook that says, oh, there's a new data set, there's a new job that just came in. Oh, bless you. And what are the inputs of the job? So we make an API call out to the Lineage service and say, okay, here's the job, and here's this input data set. But as the job itself progresses, or new iterations of job happen, you then hear, in this case, we have an output data set. So the job itself now has an output data set, so it's very easy to build out the Lineage graph. So the inputs and outputs, and the Lineage graph is represented on the right. Here we have another input that was reported, and now we have a Lineage graph with 2 inputs and 1 output. Okay, so how is Marquez used at WeWork, and also in this case, how are we deploying it? So we use Helm for defining a recipe for the service itself, and we deploy to Kubernetes. So what that workflow looks like is we version, since it's an open source project, we have to do some interesting things behind the scenes to get this to work. But I mean, we do all development in our public repos. Just internally, we do have to keep a private mirror because we have to do hot fixes. So in order to get things out quickly, we have to integrate with our Kubernetes stack internally at WeWork. So the CI pipeline is pretty standard. We run a build, run our tests, and then we push our image to Quay. And then all images that we build do get deployed to staging right away. And we do have a hold on production. So once we have our smoke tests and ensure things are working correctly in staging, we then deploy to production. Okay, so now with that, so with the introduction of Marquez, now how did we integrate Marquez with Airflow? So just a side story, at WeWork, just like all companies, I feel like there's this initiation where you have to build your own scheduler. We had our own, and it was working fine, but it really just ran SQL, and we didn't have the capabilities that Airflow provided. So early on, we were very scrappy, and then we realized, well, hold on, we need to understand why our pipelines are failing. We need to understand what's the current state of our workflow. So we chose Airflow specifically for that because it provided us a scheduler, that UI, and also those data abstractions with operators. So what does the Airflow support for Marquez look like? One, metadata collection is at the core. So when a DAG starts, we look at all the different tasks that are associated with that tag, and for each task, we report that as a job in Marquez. So we inspect the tasks, and we look at the different inputs of the task itself. But in general, we look at the entire life cycle of the task, so when it starts and when it finishes. We look at the parameters that are passed into the DAG, and we register those arguments or pass those arguments as metadata to Marquez. And then all the runs themselves, so as these tasks run, we then build out the link to GitHub that begins to version the code. So every time a task runs, we know exactly the code that was executing and ran that data process. And also we register the inputs and outputs. So those are the really foundational parts of what you get right out of the box with the library. And I'll show you how simple it is to just get started with it. And then as you report metadata around the task itself, you're then able to create and trace or track the interdependencies between DAGs. The library does have a built-in SQL parser. So this one, a lot of our workflows at WeWork is SQL-based against our warehouse. So the Marquez Airflow library has a SQL parser that looks at the tables that are part of the joins, what tables you're writing to. So we parse the SQL, we look at the tables, the library automatically registers a source and ties all those data sets to that source. And then that metadata is then sent along with the job. So previously we walked through what it takes to register a source, data set, and job. That's exactly the type of flow that's happening behind the scenes with the library. We're testing out this a URL builder that links to code in GitHub. We're still experimenting on how we want to do that, whether it becomes a configuration where you provide your base GitHub URL. But this is pretty powerful. Automatically in the UI, you get a clickable link to GitHub, and you know the version that executed. If something's failing, you can go right to the code to figure out what's going on. And then we have this concept of metadata extractors, which I'll go into in my next slides. But that's how we inspect the operator and extract the metadata from the operator itself. All right, so on the Airflow side, like we mentioned, we have these operator abstractions. And there's a one-to-one mapping. So for every operator that Airflow provides, Marquez doesn't have all of them, but internally we have some custom extractors and custom operators that execute against Redshift. So that extractor looks at the operator, does this sort of high-level inspection of the operator itself. So if it has a SQL field, that's where we use our SQL parser. And then once we extract the metadata, we then report that to Marquez. So here's an example, Postgres operator. We have that's an Airflow, and we have one that maps directly into the Postgres, maps to the Postgres extractor that's available in the Marquez library. And what really it does is, as the DAG comes up, the library looks at the operator and sees, do I have a matching extractor? And if it doesn't, it just reports the run itself. It can't really do much more than that. But if you want to get deeper and understand more about what the operator is doing, you need an extractor for it. So the Marquez Airflow library is open source. I think there's a lot of experimentation that we're doing internally, but we're gonna be pushing a lot of the code upstream within the coming weeks. The library does enable global task level metadata, as we talked. So, with Airflow, you have this one view of your DAG, but with the Marquez UI, you're able to then see a full view of all the DAGs and their dependencies. And really, what we ended up doing, we just extend the Airflow DAG class. So instead of saying from Airflow import DAG, you do Marquez Airflow import DAG, and that's it. That's all you have to do. So at a high level, when the DAG kicks off in Airflow, it starts making those API calls to Marquez. And on the back end, that's where Marquez starts building out, or it starts collecting the metadata reported by the Marquez Airflow library integration. So automatically, it's going to take that job and register it, but also register its version. And all the runs that are executed are now tied to that version itself. So if your DAG runs on an hourly basis, you're going to have 24 runs that are associated with that version itself. But also, we link the run args to the run itself. It becomes really powerful in troubleshooting why your pipeline's failing. So the way you could take a multi-tenancy approach with Airflow, or you could do multiple Airflow instances. So for us, we went with the multiple Airflow instances route. That way, it allows the teams to optimize their Airflow instance based off the type of workloads they're doing. Internally, we distribute our own Docker image, so that comes prepackaged with Airflow and also the library itself. We also make it where they don't have to change the import. So you can actually specify from Airflow import DAG or Marquez import DAG. We wanted to make it pretty easy for the onboarding process with Marquez, so we did some things behind the scenes to default to the Marquez Airflow library. And the key thing here is that all DAGs that are running at WeWork now are Marquez enabled. So it's used we're using it in production. A lot of the use cases that we do see is when someone wants to drop a column, they use the lineage graph to see what dashboards will be affected or what jobs will be affected if I drop this column. And automatically you get lineage across Airflow instances. So for us, if we have think about 10 running, we are able to then stitch the dependencies between the DAGs across Airflow instances, which becomes super powerful. And then by default, we tie the ownership to the DAG itself at the namespace level. So at the ownership should be at the team level because people, engineers and data engineers and data scientists, they move from team to team. Some leave the company, some join. So you want the ownership to be at a team level and enforce it there. So this is our high-level deployment process. So we build our image with custom operators and custom and libraries that we share across Airflow instances. Marquez is also shipped along with that image with the custom extractors that we have, and we push that image to Quay. And in Kubernetes, we leverage namespaces. So every Airflow, so the teams that are responsible for the operational side of Airflow, they deploy it in their namespace. And we have one instance of Marquez running, or multiple pods that are running, and they all report metadata to a central API. So in this case, so how are we managing interdependencies? We're working on a concept called data triggers, and it's all powered by the data lineage graph that we're building. So what data triggers means is, since Marquez knows when jobs are finishing and also when data sets are changing, we know we can then start sending messages to a bus that says, hey, you might want to kick off a process if this data set has been updated. And if there's a downstream system that's listening, in this case, it would be, we're working on leveraging the REST API that Airflow has, which allows you to trigger a DAG. So if you have one DAG that finished in one instance, and Marquez just is aware that it just updated a data set, it could then send a message, and another DAG in another Airflow instance could execute. So no polling, which is great. So right now, I think a lot of what people do is they have sensors that pretty much say, hey, is this job complete? Is this job complete, or is this data set available? So we want to remove that overhead and polling, and it's all event-based. So what that looks like is your job just finished. It just made a change to a data set, and with data triggers, you're able to then kick off another job that will then execute and produce a new version of a data set itself. But things go wrong. So with data triggers, you could also use it or leverage it for backfilling. So if you realize that something upstream failed, you could then use data triggers to kick off the downstream jobs that need to process that new data set version, or if there was gaps in the data, it could then recompute and then insert the data in the gaps. There's also a concept that we're looking into, and it's called, in this case, if you know that a data set changed, but you could apply, before you actually execute the job, you could apply a check, like a health check. Should I be executing this job? But let me check the health of the data first before I kick off the job. That's pretty critical for financial data. So you don't want to sort of kick off a pipeline if it's working on understanding the revenue, or in this case just financial data, because if there's a gap in the data itself, that really affects the numbers. So you want to have a way to stop that, a stopgap, or short circuit the execution before the job kicks off. Okay, so let's do a quick demo. I thought I had one. Oh, it moved. So here we have a vanilla Airflow running, and we have two DAGs. One is just an ETL room booking stack. Okay. And what that's going to do is going to take raw data from a table and apply some transformations, so like some filtering and so forth, and it's going to be used. The resulting output data set, the cleansed version, is going to be used by room booking 7 days. So that's just going to be a DAG that is just computing what were the room bookings in the past 7 days. So here we have the Marquez, the Marquez UI running. That was a lot quicker than I thought. So here we have a namespace. So Marquez ships with the default namespace. So if you, we associate an anonymous user. So if you just want to get up and running and you don't really know what namespaces you really want to associate or create yet, Marquez ships with the default namespace. Right. And this instance has no jobs, no data sets. So let's go to Airflow and kick off some tags. So here, we just started the ETL room bookings tag. So we're just going to refresh until the tag completes. And again, behind the scenes, we're also reporting the job state. So the Marquez UI for the initial version that we have internally, we got a lot of feedback. And the one thing that people care about is the historical runs. So that's metadata that we're collecting. But in this current UI, we're not exposing that. So if we refresh the page, we have a job, ETL room bookings, DAG raw bookings, and we have two data sets that were registered. In this case, we have the office room bookings and also the raw office room bookings itself that are part of the SQL. And here we have the lineage graph and some metadata around it. And in this case, there's no location, but it shows you. Sorry, that was really quick. But here, if we look at it, it shows the raw office room bookings as the input, and the orange circle is the job itself, and then the output data set, which is just the public office room bookings. Right? All right, so what we're going to do now is kick off the room bookings 7-stage job, which again is still running some SQL, but now it's going to use the room bookings data set that was created by our ETL job. So we're going to wait for this to complete. Okay, so let's refresh the page. Now we have a data set, a job called room bookings 7 days. But now you can see we have additional data sets registered. And those were tables that were part of the SQL that were executed in the run 7 days. But now the lineage graph looks a little bit different. We now have an upstream dependency, right? So we have raw. If we follow the lineage all the way up to raw room bookings, and we look at the office room bookings data set. In this case, I think it's a little bit hard to read the job, but the orange dot over there has 3 input data sets that it has 3 tables as input, and it's writing to. Let me actually show it again. It's just writing to a weekly office room booking, so it's the last table there. But you could also click on a data set, and if you just wanted to focus just on that data set and its lineage, you're able to render the lineage graph. Cool. Yeah. All right, so that was the demo. So what is the future? What kind of work do we have left? So here's our roadmap. So short term, we want to release 0.5.0 of Marquez, which has a lot of the learnings that in production that we've had over the past quarter. So that's going to be, there's a PR out, and we're going to be merging it in shortly and doing a release. We do want to get a Marquez Airflow release out, the 0.2, which allows you to define custom operators. We're also going to be releasing an early version of the Marquez Helm chart. So if your team's running on Kubernetes, we want to make it really simple and provide a Helm chart. And the documentation is going to get a lot better. So we're going to document how you can get up and running with Airflow, and additionally, all the other services that we're working on. Oops. Some long-term things in this case, we're starting this quarter to integrate with Apache Iceberg for collecting metadata around the file system. The search capability, that's something we're still testing internally, but we're going to start pushing more of that code upstream. And then data triggers, that's just a concept that we haven't tested, but we do feel like there's a big need, and especially we work with the number of Airflow instances that we have. Data triggers we have to build it, so pretty exciting about that. So thank you for attending my talk. That's all I got. One last thing, if you want to learn more about Marquez, we do have a GitHub site. You can check it out. And here's our GitHub page and questions. Yeah.
Okay, let's do some Q&A.
Yeah.
First up, have you listened to the Dagster talk yesterday? Do you agree with Airflow's shortcomings mentioned there? I think we talked a little about this ourselves.
Yeah, so I actually spoke with Nick very early on about Dagster. We are talking with him about integrating Marquez as a back-end metastore. Do I agree with the shortcomings? Yes, I do. I mean, right now, so I could give an example of what's going on at WeWork in terms of testing. With Airflow, there's no good, so one of the key things he talked about was testing. The way we test is we define a DAG locally, you push it to staging, but really you have to go to production to really understand, is my pipeline correct? With what Dagster's trying to do, it's bringing that all local and providing those tools to make sure that your data pipeline is correct. So I do agree with a lot of the shortcomings that Airflow does have. So really exciting project, by the way. Yeah.
Okay. What is the motivation or benefit for WeWork to make Marquez open source?
Oh, well, I mean, obviously, we want to attract a lot of talent. And, you know, the thing is for us, we are, I'm not going to say we are a tech company, but we are building out a really amazing ecosystem. And we have a lot of amazing engineers that are really well known in the data space. So these data abstractions is just for us to communicate, hey, there's a new way, there's different ways to build out the data platform. And for us, there's a need in this space. I think it's been far too long where there hasn't been a metadata solution. And we just so happen that a group of engineers that are at WeWork understand the problem. So yeah, we want to make that available to the open source community.
Okay, great. Have the metadata been successfully used for analysis? And can you give any examples of that?
Yeah, sure. So we have a central data and analytics team at WeWork, and our space, or the WeWork space, has a floor plan. And we have community leads that run the space, and they have software available to them that shows the layout. A lot of the time, it's not correct, so it's very hard to understand why that is. So we have a help desk, and they get these requests coming in, and like, hey, the layout of my office space is incorrect. So they use the Lineage graph to identify what are the tables that are feeding in the floor plan and figuring out what jobs were affecting the discrepancy. So yes.
Great, okay. Is there any integration with the Kafka scheme registry? Like, do you use the schema registry at WeWork?
We do. So we use the Confluent Schema Registry. We don't integrate, though. So this is a really good question, and one I'm pretty excited about. As events are coming in and through our event collector API, what we do is we register the topic. So we talk about the logical name and the physical name of the data set. But depending on the type of data set, there's additional metadata fields that are accessible. So we provide a schema location, which is just a pointer to the schema registry. And that's how we version topics. So when your schema registry for your Kafka topic changes, there's a new version is created in Marquez, and that's how you could start capturing the stream lineage, but also the versions of the stream. Yeah.
Okay. Do you have support for Hive tables as input sources?
No, we don't. But well, the thing is, with Marquez, it's not specific to a source. I mean, if you saw the type of metadata we have to collect, it's just a matter of adding a type to our source and providing the connection URL. And then also based off the type, there might be additional metadata that we want to collect. But whoever asked that question, if you want to talk to me after and figure out ways you could contribute, that'd be amazing. Yeah.
Okay. How can Marquez detect data lineage that is not defined as a job in Marquez?
It can't. So I think that's the key thing here. You know, it's really going in and making it very, very hard to not use the library. So that's why with the Marquez integration we have with Airflow at WeWork, we don't require anyone to modify their code. It's just done automatically. There's no other way. I mean, for us to gain visibility, it's all done through the integrations, and that's how we begin to understand and build out the Lineage graph. Yeah.
All right. What data quantities are you working with at WeWork?
Data quantities?
Mm-hmm.
I guess so for me, I'm just on the Marquez project, and that's all I work on. So I don't really expand beyond just the Marquez project itself.
Okay.
Yeah. So I don't know if I answered that question, but yeah.
Okay, that's okay.
Yeah.
About data model, how one run can have many data versions? How can one run have many data versions?
Data set versions, right? Yeah. Well, one run will produce a data set version. So there's a one-to-one mapping, and every time a job run is an instance of a job version, and those produce data sets. But there's a one-to-one mapping. A a run won't have multiple dataset versions unless it has multiple outputs. Then it will have multiple versions, but of a different data sets. Yeah.
Okay, great. Well, thank you so much, Willy.
Okay. Thank you.
This is on behalf of the conference.
Wow, thank you.
And Willy will be at the Prezi booth in the sponsors hall doing office hours for the next 20 minutes. And yes, round of applause, please.
All right, thank you.